Hello friends. I am Satish Lele. This video is part of my chemical process typing channel on YouTube. This video is about Hazop or Hazop. It is Hazard and Operability Study. We will study summary of Hazop analysis, limitation of the Hazop technique, procedure for Hazop analysis, Hazop about actual process. Summary of Hazop analysis. What is Hazop? Brief summary of characteristics. Most common uses. What is Hazop? A hazard and operability Hazop study is a structured and systematic examination of a plan or existing process for operation in order to identify and evaluate potential hazards and operability problems, or to ensure the ability of equipment in accordance with the design intent. The Hazop analysis technique uses the systematic process to identify possible deviations from normal operations and ensure that appropriate safeguards are in place to help prevent accidents. It uses special adjectives combined with process conditions to systematically consider all credible deviations from normal conditions. The adjectives, called guide words, are a unique feature of Hazop analysis. In addition to its utility in quality risk management, Hazop is also commonly used in risk assessments for industrial and environmental health and safety applications. Hazard. Potential source of harm. Deviations from design or operational intent may constitute or produce a hazard. Hazards are the focus of Hazop studies, and it should be noted that a single hazard could potentially lead to multiple forms of harm. Harm. Physical injury or damage to the health of people or damage to property or the environment. Harm is the consequence of a hazard occurring and may take many forms: patient or user safety, employee safety, business risks, regulatory risks, environmental risks, etc. Risk. Combination of probability of occurrence of harm and the severity of that harm. In a strict sense, risk is not always explicitly identified in Hazop studies since the core methodology does not require identification, also referred to as rating of the probability or severity of harm. However, risk assessment teams may choose to raise these factors in order to further quantify and prioritize risks if needed. Uses. Hazop is best suited for assessing hazards in facilities, equipment, and processes and is capable of assessing systems from multiple perspectives. Design. Assessing system design capability to meet user specifications and safety standards. Identifying weaknesses in systems, physical and operational environments. Assessing environment to ensure system is appropriately situated, supported, serviced, contained, etc. Operational and procedural controls. Assessing engineer controls such as automation, sequences of operations, procedural controls such as human interactions, etc. Assessing different operational modes: startup, standby, normal operation, steady and unsteady states, normal shutdown, emergency shutdown, etc. Brief summary of characteristics. A systematic, highly structured assessment relying on Hazop guide words and team brainstorming to generate a comprehensive review and ensure that appropriate safeguards against accidents are in place. Typically performed by a multidisciplinary team, applicable to any system or procedure. Used most as a system-level risk assessment technique. Generates primarily qualitative results, although some basic quantification is possible. Most common uses. Used primarily for identifying safety hazards and operability problems of continuous process systems, especially fluid and thermal systems. used to review procedures and sequential operations. The limitation of the HAZOP technique. It requires a well-defined system or activity. The HAZOP process is a rigorous analysis tool that systematically analyzes each part of a system or activity. To apply the HAZOP guide words effectively and to address the potential accidents that can result from the guide word deviations, the analysis team must have access to detailed design and operational information. The process systematically identifies specific engineering safeguards, for example, instrumentation, alarms, and interlocks that are defined on detailed engineering drawings. Time-consuming. The HAZOP process systematically reviews credible deviations, identifies potential accidents that can result from the deviations, investigates engineering and administrative controls to protect against the deviations, and generates recommendations for system improvements. This detailed analysis process requires a substantial commitment of time from both the analysis facilitator and other subject matter experts, such as crew members, engineering personnel, equipment vendors, etc. Focuses on one event causes of deviations. The HAZOP process focuses on identifying single failures that can result in accidents of immersed. If the objective of the analysis is to identify all combinations of events that can lead to accidents of immersed, more detailed techniques should be used. Procedure for HAZOP analysis. Definition of some useful items. Define the system or activity. Main process of the HAZOP analysis. Conduct HAZOP reviews. Use the results in decision-making. Node. Node is some specific sections of the system in which the deviations of the design and process intent are evaluated. The node can be a subsystem, a function group, a function or a subfunction. Deviation. A deviation is a way in which the process conditions may depart from their design and process intent. It is created by combining guide words with process parameters resulting in a possible deviation from design intent. Process parameters. The process parameters is the relevant parameter for the conditions of the process. For example, voltage, data, direction, etc. Guide words. The guide words, or secondary keywords, applied in conjunction with a primary keyword. These suggest potential deviations or problems. For example, less, more, no, reverse, etc. HAZOP guide words used for deviations of detergent control for cleaning operation. Define the system or activity. The system boundaries should be specified and clearly defined. By doing these, analysts can avoid overlooking key elements at interfaces. Main process of the HAZOP analysis. Divide the system into sections and develop credible deviations. Determine the cause of the deviation and evaluate the consequences and problems. Find the safeguard which help to reduce the occurrence frequency of the deviation or to mitigate its consequences. Recommend some actions to against the deviation more effectively. Record the information. Repeat procedure. Form to record the information. Procedure diagram. Conduct HACRP reviews. Introduce the team members. Describe the HACRP approach. Conduct the analysis. Use the results in decision-making. The report. Judge acceptability. Identify improvement opportunities. Make recommendations for improvement. Justify allocation of resources for improvement. Team for Hazop analysis. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.